Welcome to our new unit in which we're going to be talking about equations and graphing and slopes and all kinds of good stuff. To start our unit today, we're going to talk about proportional relationships. Again, you say that, proportional relationships. So amounts change sometimes. We have money in our bank accounts that goes up or down. As you grow, or trees grow, or flowers grow, heights can change. Bacteria cells or cells in your body can change at any given time. We're going to take a look at how much they change over a period of time. So my example for you to start off with is maybe you're putting $100 per month in a bank account. And we're going to call that the rate of change. So again, how much something changes over a period of time is called rate of change. We're going to start off with one example. We're going to have a bank account where our X column is the number of years that we've had that bank account, and Y is going to be the amount of money in our account or account balance. So when X is 0, that means that I have had my bank account for 0 years. This is where I open my account. When I open my account, I have $0 to start with. After 1 year, I have $200 in the account. After 2 years, I have $400. In 3 years, I have $600, and in 4 years, I have $800. So how does our account change? What's going on between the number of years and the amount of money? Well, we're going to say that this bank account is increasing, if I can get the pen to work, increasing $200 each year. Is that a fair assessment? We went from 0 to 2 to 4 to 6 to $800. We're increasing $200 each year. This unit, we're going to learn how to take this scenario and create an equation that will match. So I'm looking for how I can get my Y value from my X value. The same thing happens. See if you can see a pattern. How do I get from 0 to 0, from 1 to 200, from 2 to 400, from 3 to 600, and from 4 to 800? Hopefully you've discovered that I'm taking the year and multiplying it by 200 to get the amount of money in my account. We're going to create an equation there that says to get my Y value, I'm going to take 200 times my X value. It's important to know what our X and Y stand for, okay, where X is the number of years and Y is the balance in our account. But Y equals 200X would be the equation to match this chart. Then we're going to take that information and we're going to put it on a graph. Now my X values here are going by ones, where my Y values are going by hundreds. That's okay as long as you label the different axes. So this is years, this is dollars. I'm going to take these X and Y values and make them points. So my first point is going to be 0, 0. My second point is going to be 1, 200. 2, 400, 3, 600, and 4, 800. Look close at the information on the graph. What kind of pattern is it making? We're going to take that pattern and use it to our advantage. Notice how it's creating this nice straight line. We're going to continue. We're going to put an arrow on the end of the line to say that this is going to continue. We're going to continue to deposit money in our account every year, and it's going to continue to increase in value. So one thing that you want to look at here is this makes a straight line. That's going to be important for us later. What is the graph telling us? It's telling us that the bank account has a steady rate of increase or rate of change. It's always increasing by $200 per month. It's never varying from that amount. How is that going to help us? Well, we can learn to predict how much money we're going to have in the future, or maybe you have a goal of an amount of money that you're trying to reach, and you can find out how many years it's going to take you to reach that goal. So they can be really beneficial to us, especially if we're in a situation like a business where we need to make a certain amount of money. Here's a different scenario. We have a scientist that, let's fix this. We have a scientist that's looking at cells, right? He found out that he had 800 cells of bacteria. After quite a while of monitoring, he found out that his cells have a half-life of 1 hour. Half-life means that half of the cells are dying off within that hour. So we're going to take a look at that in our graph. After 0 hours, that's his starting point, he had 800 cells of bacteria. After 1 hour, how much is he going to have? 400 cells of bacteria. Now in the second hour then, we're going to have half of these 400 cells die off. So after the second hour, he's going to have 200 cells. Then in the third hour, he'll have 100. And how many will he have in the fourth hour? 50. So X is going to be number of hours, where Y is going to be number of cells. We're going to take that information and put it on our graph. Again, our x-axis is for number of hours, and our y-axis is going to be for number of cells. So my first point is going to be at 0,800. That's how many cells we have in the 0 hour, or when we begin. After 1 hour, we have 400 cells. After 2 hours, we have 200. After 3 hours, 100. After 4 hours, 50. This pattern's going to continue, so after 5 hours, I'm going to have 25, then 12 and a half. Then, it's going to keep cutting in half and in half and in half. When we draw in a line to kind of visualize the pattern, is this the same type of line we had before? No, this is definitely not a straight pattern anymore, is it? This is definitely a curved pattern. Here's a quick question for you. If I keep taking half and half again and half again, am I ever actually going to reach 0 cells? The answer is no. I'm going to get really, really close to it. I'm going to get into some really, really small numbers, but I'm never actually going to reach 0. So my question is, does this graph have a steady rate of change like our last example did? Answer is a big fat no. Situations like we had before, where you're going to start with nothing and have a steady rate of change, we're going to call those proportional or proportional relationships. So again, this is an important term that needs to be in your notes. Situations where you start with nothing and have a steady rate of change are called proportional. So we're going to go back a couple of screens to our first graph. Notice how we went through the point 0, 0. That's what they mean when they say start with nothing. And this straight line is telling us we have a steady rate of change. That's what makes something proportional. If we take a look at the graph for our cell example, this did not start at 0, 0, and it definitely wasn't a straight line, does not have a steady rate of change, so this example would not be proportional. We're going to do that same thing with just regular equations. Sometimes you won't have a scenario. You're just given an equation to work with. We need to be able to do the same thing with our equations. So let's take a look. Here we've got an equation y equals 2x. That means multiply your x value by 2 to get your y value. So here in the middle column, we're going to put 2x. We're just going to pick some random values for x. I'm going to put them in order from -2 to 2, just because those are the numbers I chose. You might pick different numbers than me. Totally okay. We're going to get the same result. In the second column, I'm going to take the x value that I chose and multiply that by 2, 2x. In this case, 2 times -2 is going to give me -4. I'm going to take my x and my y value to create a point. X value first, y value second, gives me the point -2, -4. Next, I chose -1, so I'm going to do 2 times -1 gives me -2. So I now have the point -1, -2. If x is 0, I'm going to do 2 times 0, which is 0. That's going to give me the point 0, 0. 2 times 1 is 2 for the point 1, 2. And finally, 2 times 2 is 4, gives me the point 2, 4. We're going to put that on a graph. So we're going to start with -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. What kind of pattern is this making? Yep, we've got our straight line again. Let's draw in the line that matches with this pattern. Oh, I totally messed that up. Let's try again. Let's draw in the line that matches that pattern. This is a lot easier to do with a ruler, so you'll probably want a ruler when you start graphing these lines. I'm going to put arrows on both ends to show that this pattern is going to go on forever. Note how we go through the point 0, 0, and this is a straight line. Is this graph proportional? Yes, definite yes. We go through the point 0, 0. It's a straight line, which means steady rate of change. That's what gives us a proportional situation or relationship. What types of life situations would match this graph? Notice how your y value is increasing by 2 every time our x value goes up by 1. So you could say something like, something where it's going to increase by 2. Maybe you're only getting paid $2 an hour, and for every hour that you work, your pay is going to increase by $2. That would be a life situation that matches this graph. One more, then we'll give it a rest. Let's try a graph for y equals 1/2 x plus 8. Now to choose values for x here, notice how I have to take half of our x value. So since taking half of a number is easier when they're even numbers, I'm going to choose only even numbers. It doesn't matter. This is just my choice. So in my second column over, I'm going to take half of that x value and then add 8 to each one. So half of -2 is -1, and -1 plus 8 is 7. So I'm going to get the point -2, 7. I put -2 into my equation and got a positive 7 back. If I take half of 0, this is having a hard time writing. Half of 0, that's 0. When I add 8 to that, I get an 8. And so my next point is 0, 8. Half of 2 is 1. 1 plus 8 is 9. So my next point is going to be 2, 9. Half of 4 is 2. 2 plus 8 is 10. So my next point would be 4, 10. What am I going to get if I take half of 6 and add that number to 8? 11. So our last point in this table is going to be 6, 11. Notice how my x values, I chose to have them go up by 2 each time. And what happened to our y values? They only went up by 1. Let's see what happens when we put that on a graph. My first point was -2, 7. My next point was 0, 8. Then we had 2, 9, 4, 10. And 6, 11 isn't going to quite fit on our graph. It'll be up here a little ways. So I'm just going to use that scenario or those points to create my line. I have to keep in mind that this line is going to go in both directions. And again, this is easier when you use a ruler so that you can just make your line going across the page. Is this graph proportional? What's your vote? Remember that the requirements for being proportional, we had to go through the point 0, 0, and it had to be a straight line. So what do you think? This would be a no. Even though it is a straight line, it doesn't go through the point 0, 0. And that makes it not proportional. Remember to write down any questions you have so that you can ask me tomorrow in class. Have a good night, and I'll see you then.